geometric series. Now we're at 1.4. Kind of combining what we've learned in the past few lessons. We know that geometric is talking about multiplying by a common ratio. And series from 1.2, when we did arithmetic series, series was taking the sequence, commas in between, and adding it up, or the sum of all of the terms of the sequence. All right, God wants us to do these geometric series. He wants us to be fruitful and multiply. And I know everybody always wants to say, hey, what happens if we have something like, let's say, 16, 8, 4, 2, ... That's a geometric sequence, and people always want to say, well, is that multiplying or is that dividing? Because we're dividing by 2 all the way along. No. Geometric, we're always going to be talking about multiplying. Amoeba, on the other hand, amoeba, they divide. We're always multiplying. So we'll be talking about multiplying by an r of 1/2. That's the multiplying to the next level. All right, getting started. 2 geometric sequences have the same first term, but the common ratios are opposite integers. Again, when does that happen? It happens when we're looking for the r value, and we had something with an even exponent, such as r squared equals some number. And then we take the square root, and we get plus or minus. Or in other words, if we're given this number and let's say that number, I don't know if I'm going multiplying by a positive or a negative, because this one could be plus or minus, and back to positive. And that was explained in the 1.3 video there. So which terms are going to be the same and which terms are going to be different? How does this affect all the way through? Pause it if you haven't done so yet. Work this one through. Do the thinking yourself. All right, I'm going to pick first term. I'm just going to pick 3 for the first term. Common ratio, I'm going to pick plus and minus 2 for that one because we need both. So we've got, let's do 6 of them there to start with. If r equals positive 2, then the first term was 3. Then the next one's going to be 3 times positive 2, which is 6. Times positive 2, 12, 24, 48, 96. All of them are positive all the way through. Now, what happens if r is negative 2? First one's going to be 3. Multiplied by negative 2 gives us negative 6. Multiplied by negative 2 gives us positive 12. Negative 24. Positive 48, negative 96. And those will go on forever. All right, which ones are the same? Well, the first term was the same. The third, the fifth, and of course going to be the 7th, the 9th. Which ones are going to be different? They're going to be opposite signs on the 2nd, the 4th, the 6th. So it has to do with even and odd term number all the way through. All right, application of geometric. You've got your family tree. Okay, and traces all the way back. Determine the total number of direct ancestors in 20 generations. Again, pause, you haven't done this question yet, work it through and then come back in and see, did you understand, did you make the connections that you needed to? Making the connections yourself, you're going to remember this stuff so much more. All right, so we start with Caitlin there. In the first generation, she has 2 ancestors. She's not an ancestor of herself, so we don't count that. Don't count her. In the second generation, she's got 2 sets of grandparents, so there's 4 people there. But how many descendants does she have? How many ancestors does she have? After the second generation, she's actually got 6 ancestors. Ooh. Let's keep that going now. I suggest in this, make a table for yourself. All right, so we've got a table something like this. In generation number 1, the number of people was 2 in there. So the total was 2. In generation number 2, there's 4 of them. So then that's going to be 2 plus the 4, which gives us a 6. In generation number 3, there'd be 1, 2, 3, 4, 5, 6, 7, 8, which would be 6 plus the 8, which gives us the 14. Hey, look at, there's a pattern going there. We're multiplying each one going up by 2. Let's just follow that pattern along. Math's about patterns. Look for the patterns. Find what works. So then that's going to be 16, 32, 64, 128, 256, ... That's going to keep going that pattern. And then we're just going to keep adding. 14 plus the 16 gives us the 30. 30 plus the 32 is going to give us 62. 62 plus 64 is going to give us 126. 126 plus 128 is going to give us 254. 254 plus 256 equals 510. Hopefully you can start looking at those numbers. Those numbers are all quite related. That second number that we're adding to is always 2 more than the number that we had the sum before. The next one's always 2 more. Oh, that's interesting. So start playing around. Try to find a pattern for yourself. And what we could actually start seeing as well, a couple different ways, is that the first generation could have been thought of as, let's say, 4 minus 2, or 8 minus 2, or 16 minus 2, all the way along, or 32 minus 2. Another pattern that's emerging to get the same value. Well, 4, 8, 16, 32, those are numbers that are actually powers of 2. So we could also say, hey, this is something like 2 to the 2 minus 2, 2 to the 3 minus 2, 2 to the 4 minus 2. And then at that point, we can make a nice connection and say, oh, how does this value work with the generation number? Oh, look at, there's a relationship. So I could talk about the 20th generation. And I could say 2 to the 1 more, 21, minus 2 equals 2097150. Now, that's not the only way to get to the answer. You could have found the answer many different ways. But look for patterns in numbers. Make connections yourself. All right, so geometric series is just taking our geometric sequence and adding it up, putting plus signs in between. First term 6, second term, take the 6, add the 12, then now add the 24 in the mix. We can talk about the nth term and the sum of the nth term. Now we've got these partial sums here from 4 to 2, 9, 1, 6. I'm going to stop explaining this one to you. I've got a lady who said, oh, hey, can I explain to them? Sure, she can. And here she is.
We can develop a rule for determining the sum of the first n terms of a geometric series. Consider the first 7 terms of the geometric series 4 plus 12 plus 36 plus 108 plus 324 plus 972 plus 2,916. We want to determine the sum of these 7 terms, S7. There are 7 terms, so n equals 7. The first term, T1, is 4. The common ratio, R, is 12 divided by 4, which equals 3. We can multiply each side of the equation by the common ratio, 3. Looking at the right side of this new equation, notice that if we shift the terms to the right, they match up with terms in the original equation. Next, we subtract vertically. On the left side of the equation, we have S7 minus 3S7. On the right side of the equation, we have 4. Then, 12 minus 12 equals 0. 36 minus 36 equals 0. We continue to subtract each pair of matching terms until finally we subtract 8,748. So, S7 minus 3S7 equals 4 minus 8,748. S7 minus 3S7 is negative 2S7, and 4 minus 8,748 is negative 8,744. We divide each side by negative 2 to get S7 equals 4,372. So, the sum of the first 7 terms of the series is 4,372. If we look at the numbers in the equation and relate them to n, T1, and R, we can develop a general rule for determining the sum of a given number of terms in any geometric series. First, we can write 8,748 equals 4 times 3 to the power of 7. N equals 7, so we can replace the 7's in the equation with n. T1 equals 4, so we can replace the 4's in the equation with T1. R equals 3, so we can replace the 3's in the equation with R. Now we have Sn minus Rsn equals T1 minus T1 r to the power of n. We can factor out a common factor of Sn on the left side of the equation, and a common factor of T1 on the right side. Now, to isolate Sn, we divide each side of the equation by 1 minus r. So, for a geometric series with first term T1 and common ratio r, the formula for the sum of the first n terms, Sn, is Sn equals T1 times 1 minus r to the power of n divided by 1 minus r. We can develop.
That was intensely cool. It always makes things so much easier when you've got a formula that you can follow. And that's what we've got here now. So we've got this formula, which is on your formula sheet, to be able to do your sums. So the question here that I want you to write down and we can discuss is, why is 1 not allowed? And that's referring to this right here, that said r cannot be equal to 1. And let's do the work now here. Example 1. So you're copying down there, page 45 right on the side. And we've got, determine the sum of the first 12 terms of this geometric series. Well, they said sum and series and geometric, so we know we're using this formula. Sn equals T1 bracket 1 minus r to the n over 1 minus r. But if you notice on the side column there, they asked this question, what about this? This is also the same equation. All we've really done is we factored some negatives out. And this is the one that actually I've put on your formula sheet for you. So this is the formula that I'm going to use. So I'm going to have you write that one down next to your formula box there. So we'll say Sn equals T1 bracket r to the n minus 1 over r minus 1. So that's the formula I'll use from now on. Formula-based question. Let's write down all of our stuff on the side and see what we know and what we're looking for. So Sn, T1, R, and N. Sn, that's the sum, that's what we're looking to find. T1, that's our first term, that's 3. R, ooh, we got to calculate that. R is found by T2 divided by T1, or 12 divided by 3, which is 4. Hey, check it just to make sure. 48 divided by 12. Oh yeah, that's also 4. 4 is a good number to use. And N, first 12 terms. Plug her in, let's work it through. So S12, sum of the first 12, is equal to 3 times 4 to the 12 minus 1. Careful with that. That minus 1 is not in the exponent. It is 4 to the 12 minus 1. So let's do this. Not r to the n minus 1. Careful with that. And this was over r minus 1. And you could plug it into the calculator right as such. Boom, get to the answer. Careful with your brackets. I recommend just taking it a little bit step by step. And we've got 3 times 16777 minus 1 over 3. Oh, look at that. 3 divided by 3. Hi, that goes down to 1. Now we've got 16777 minus 1. Oh, well, that's 16777 215. There's the sum. Well, let's go a little bit tougher here. The sum of the first 14 is that, and the common ratio is that. What is T1? Well, I've got Sn, T1, R, and N. Fill in what we know. Sn. Hey, I know that. That's the sum. They told me that it was 16383. T1. Ooh, I'm looking for that one. R. Ooh. That's negative 2. And N, hey, first 14 of them. Start with your formula. Sn equals T1 r to the n minus 1 over r minus 1. And fill her in. 16383 equals T1 negative 2 in brackets to the 14 minus 1 over 14 minus, oops, negative 2 minus 1. Be very careful with brackets on this. I know where people are going to be making their mistakes, and it's right here. Let's take her step by step, working it through. 16383 equals T1 times negative 2 to the 14 is 16384. Positive. That's a even exponent. That negative has to be inside the brackets if you plug it into your calculator. Minus 1 over, that's going to be negative 3. multiply that negative 3 over. And that now gives us negative 49149 is equal to 16383 T1. Divide that over. And that's going to give us T1 is equal to negative 3. So how can you check that negative 3 was the right answer? Put something in there. That's our discussion question in class there. Alrighty, getting trickier now. Calculate the sum of this series. So again, hey, sum of this geometric. So that means we've got Sn, T1, N, and R. Okay, so we've got Sn, oh, that's what I'm looking for. T1, hey, I know that, that's negative 3. R, hey, we've done that many times, negative 15 divided by negative 3. Oh, look at that, it's 5. Check just to make sure, 15 times 5, does that give me 75? Yep, so R is 5, but wait. I don't know how many places I have. Nowhere did they tell me what the n value is. I do know that this is the last term, Tn. So we're going to have to go back to the last section there in 1.3 and say, I need to calculate the n value. How do we do that? Thanks for asking. We're going to use our formula from 1.3. Let's fill in what we know there. Tn, I know, was negative 46875. T1, I can see, was negative 3. My R value, I know, is 5. Oh, look at that. I've got an n minus 1 there that I can work with. Let's divide that negative 3 over. And that gives us now 15625 is equal to 5 to the n minus 1. Ooh, but you don't have the algebra skills yet to solve for an exponent. That's all right. We don't need to do it algebraically. We're going to do it with a little bit of guess and check. We do know that 5 to the something has to equal 5 to the something on the other side. So we're going to try to figure out 5 to the what gives us 15625. You pull out your calculator, you're going to just do a bit of guess and check all the way through, and we find out, oh, lo and behold, 5 to the 6 is 15625. So that means that that 6 has to be the n minus 1. So then 6 equals n minus 1. Add 1 over. So then n is equal to 7. Yay! But we're not done. All we did is we calculated the n value. Now we're doing the sum. So start with our sum formula. Sn equals T1 bracket r to the n minus 1 over r minus 1. Let's fill it in. T1 negative 3 bracket 5 to the 7 minus 1 over 5 minus 1. Whoops, that doesn't look like a good minus. All right, so negative 3 times, that would be 78125 minus 1 over 4. And so 78124 times the negative 3 is going to give us negative 234,372 divided by 4. We get a value of negative 58593. There is the sum of this series. All right, you got a chest infection, lovely. You go to the doctor, antibiotics, 500 milligrams inside each tablet. Then you have to take it by this next time. That's when you take the next pill. Well, 15% of the antibiotic is still remaining in your body. The rest has been metabolized and gone. So that means, when we look at this, that 15% is remaining. It's still percent, so we've got to talk about 0.15. Got to take it to a decimal. But I don't have to add the extra 100 because 100% and then 15 is not sitting. All you have is actually 15% still in your body, or 0.15 of the amount is there. That does give us our R value this time. Let's make a quick little table just so you can see what's happening. After you take the first tablet, you got 500 milligrams sitting in your body. Then, when it's time for the second tablet, you take the second tablet, you're putting in 500 milligrams into your body. But wait, there was 15% of that first tablet still sitting in your body. Then when we go to take time to take the third tablet, you take the third tablet, you've got 500 milligrams in your body now. But you've got 15% of the second tablet that you took. And then you've got 15% of the 15% of the first tablet you've got. Woo! The heck did I just say? We need some color coordinating going on there. Third tablet, second tablet, first tablet. That's how much of each tablet is still in your body. Punching that through, that's going to give you 586.25 milligrams right there. But we want to be able to use a formula. So let's go to the 10th tablet and see how we can use a formula to be able to do this. We got Sn equals T1 times R to the n minus 1 over R minus 1. Okay, so the first tablet, that was n equals 1. Second tablet was n equals 2. Third tablet was n equals 3. 10th tablet, oh, that's going to be n equals, oops, not 3, 10. There we go. T1, that's the 500. So we're looking for the S10 here. 500 bracket. Hey, my R value, we just identified that up there. 0.15 to the 10 minus 1 over 0.15 minus 1. Okay, so after 3 tablets, we had 586 milligrams. Now we're going way more tablets. We're 10 tablets down the line. It kind of seems maybe we should have a lot more of this antibiotic in our body. Let's see what the math says here. And so when we go 0.15 to the 10 minus 1, that actually gives us a little tiny number of negative 0.999, it keeps going on, a bunch of things going on there. And then 0.15 minus 1, which is negative 0.85. Now, you got to make sure that 0.15 to the 10 minus 1 you've stored in your calculator, or do it all in one shot, that whole numerator. Because you don't want to be punching in decimal numbers that you've created. So I'm going to recommend you do it in one shot right off the bat. And when you do that, you come up with 588.2352 ... Whew, not much more than what there was to begin with. So make a quick note for yourself, the difference between the two parts. And please do those last 2 questions so that you have something to discuss in class and you're prepared for that.